The concept of fusion has been introduced. Now we would like to discuss the development of fusion as an energy source. Fusion as an energy source has a number of attractive features. Seawater contains deuterium and lithium, the basic fuels for fusion. There is sufficient deuterium and lithium for many centuries of global energy supply. These basic fuels are readily available or can be produced globally. Supply of these fuels should therefore be less sensitive to the geopolitical influences that impact upon oil and gas prices. This should result in greater energy independence for many countries. Although fusion power, like the majority of major construction projects, will produce carbon dioxide during the building of the power plants, the emissions during operation, as the power plant is used to generate electricity, are very low and related to the power plant management rather than electricity production per se. This means that over its lifetime, the CO2 emissions from a fusion power plant are relatively low and are in fact comparable to some forms of renewable energy generation. Unlike nuclear fission power plants, there is no chance of a runaway reaction for fusion. Also, by applying nuclear ALARA, as low as reasonably achievable safety principles to operational risks during power plant design, the overall risks to communities and the environment from accidents involving fusion are very low. Once constructed, fusion power plants should operate continuously, ensuring a steady and secure electricity supply. This form of electricity is compatible with existing national electricity networks that transport electricity from the point of generation to where it is used. This differs from many renewable energy sources, which tend to produce electricity intermittently, and where there would be a need to invest in energy storage technologies to support their large-scale connection to these electricity networks. In addition, there are benefits from an aspirational big science program, such as fusion. Students are encouraged into science and technology, and the program provides training in many cutting-edge, mission-focused, high-technology science and engineering areas. This favours the development of technical, scientific and management skills that can be transferred to benefit the wider national economy. The research and innovation that is occurring in relation to nuclear fusion power is leading to discoveries and the development of new products that are being applied in other contexts. For example, new materials analysis techniques which have been used to analyse space dust from the Hubble Space Telescope, and tungsten fibre reinforced composite materials which can be used in demanding high-temperature environments such as heat exchangers and jet engines. Finally, the international research programmes that are aiming to develop nuclear fusion, such as the Eurofusion Consortium and ITER, bring scientists and engineers together from a wide range of backgrounds and disciplines to work together, encouraging international and interdisciplinary collaborations and furthering international understanding.